LANDFIRE is a program partnership between the USDA Forest Service, Department of Agriculture, U.S. Department of Interior, and the Nature Conservancy. And we'll talk a little bit more about that at the end of this presentation as well. We'll go on for about 45 minutes, and we'll have plenty of time for Q&A at the end. And again, if you'd like to ask questions during our presentation, go ahead and write them in the chat window. So Don, I'll turn this over to you now, and you can get started.
Okay, thanks, Judy. And I think I'll set this up to full screen. And hopefully that works for everybody. Let us know if you're having any problems seeing that. So, to get started, first off, I'd like to thank the Nature Conservancy and the Rockies Fire Science Networks for inviting me to be part of this webinar series. The few presentations that I've been able to catch both with the Rockies and Northwest series have been really great. And then secondly, I'd like to apologize in advance for any sniffling, sneezing, or coughing you may hear on my end because I am fighting off a cold right now. So if my voice sounds a little funny, that's probably the reason as well. As Jeannie mentioned, today I'll be discussing the critique and modification of LANDFIRE data for local application.
The host has the recording feature on.
And I assume that some of you have seen Corey's presentation on this topic earlier in the month that she gave to the Northwest group. And Corey's focused on critiquing and modifying biophysical setting and succession class data for use in vegetation departure modeling. Whereas this presentation is going to be similar, except I'm going to have the focus on critiquing and modifying fuel data for fire behavior models. So as a presentation overview, we're going to begin by discussing some of the reasons for critiquing LANDFIRE data. We will then, I'll introduce a 5-step data review process that Corey and I have come up with to help frame this discussion. I'll then an interpreted example using data from the Bridger Teton National Forest, real LANDFIRE data in that area. And finally, I'll conclude with discussing a little bit about what it takes to critique and modify LANDFIRE data, and also some available resources and support. Some of the reasons why we may critique, we may ask why we critique LANDFIRE data. But perhaps the most obvious reason is that all data should be critiqued, and LANDFIRE data are no exception. So, geo-spatial data may contain errors or accuracy issues. But I want to make a point here that these terms are a bit scale dependent. So most of us probably know that LANDFIRE data was designed to be used at national and regional scales. So what we may view as an error or an accuracy issue at the local scale may not necessarily be the case when we're talking about the scale and purpose for which the data were designed. So I find this to be especially true with the fuels data. Fuel models, which I'll discuss a little bit more as we get into the presentation, are mapped at the map zone level, and LANDFIRE map zones range between 12 and 60 million acres in size. Fuel models are also mapped with a rule-based approach, so what fits best at the map zone may not actually fit best locally at your finer scale. So geospatial data may also be out of date. This would be another reason to critique it. And we know that LANDFIRE data is typically 3 years out of date when it is released. And this is just the reality of the process that it takes to develop it. But in the big picture, especially in the fuels world, I don't find that to be all that bad or all that big of a deal. 3 years is actually a pretty short time frame for data currency. A lot of the fuels data I've worked with in the past can be up to 10 years out of date. So that's not a huge issue. The geospatial data may also be using an inappropriate classification system for your objective. And a LANDFIRE example on that point would be that the vegetation data in LANDFIRE uses the nature served ecological systems classification, whereas if your project requires cover type data, then you may need to either find another data source other than LANDFIRE or work on some sort of crosswalk between the cover type and ecological systems that works for your area. data or just boots on the ground knowledge? Going to the next slide. So I'm sure that most of the folks on this call today are familiar with where the Bridger Teton National Forest and Grand Teton National Park are. But if not, it's located in the northwest corner of Wyoming, just south of Yellowstone National Park. And the area I've chosen to use for our example landscape is shown in that red box on the slide. And it's just northeast of the town of Jackson, Wyoming. So what this slide shows is a 5-step conceptual model that Corey Blankenship and I came up with to help frame the critique and modification process. So step 1 is to define your assessment objectives. And defining your objectives up front really helps you determine your data requirements and also the level of critique and modification that you may need or may not need to perform. Step 2 is to identify your data requirements, and again, this is highly connected or greatly connected to what your objectives are, but different assessments are going to require different types of data. So for example, a fire behavior assessment is going to require geospatial data of fuel, forest canopy characteristics, and topography, whereas a vegetation departure assessment, like Corey discussed earlier in the month, would require geospatial data of biophysical setting and successional classes. Step 3 is to perform your initial data review. So you may ask yourself questions such as, are the data current? Are the thematic and spatial resolution appropriate for your objectives? Are there any obvious errors in the data? And are the data assumptions in line with local knowledge? What you'll also notice is that we have those black arrows going back and forth between steps 2 and 3. And this is to indicate that this is an iterative process, and that you may find after your initial data review that you need to redefine what your data requirements are. Step 4, the revised step, is the most technical step. And this is where we actually make the revisions based on the findings of our data review. Again, there's arrows indicating that this is an iterative process, because after you revise your data, you may want to go back and review your revisions to make sure they came out the way you anticipated. And then finally, step 5 is to conduct your analysis. And the theme of iterative process continues in that you may want to go back, or sometimes an analysis will result and shed light on issues or problems that we didn't realize we had in the beginning, and we might need to go back and still make some further revisions. So I'm now going to begin stepping through our interpreted example here. So step 1, define assessment objectives. My objective then is to assess wildfire hazard under 95th percentile August weather conditions with temperature, humidity, and wind speed and direction. And use this data using LANDFIRE data. So I just want to point out, as this slide sort of indicates, is that wildfire hazard assessment itself is really a multi-step process. And it can include an analysis of weather, ignitions, and of course fuel, which is what we're going to focus on for this presentation. So given my objective of assessing wildfire hazard, I need to now identify my geospatial data requirements. So spatial fire behavior modeling requires data layers of surface fuel, forest canopy fuel, forest canopy characteristics, and topography. So for those not familiar with fire behavior modeling, or as a review for those that are, I'll quickly go through each of these and just say a little bit about what they do. So a fire behavior fuel model we'll discuss more in the next slide, but it is also simplifies the fuel-like characteristics for prediction of surface fire behavior. Forest canopy cover influences your mid-flame wind speed and dead fuel moisture content. Forest canopy height also influences your mid-flame wind speed and the potential for embers to produce spot fires. Canopy base height is a factor in determining crown fire initiation. Canopy bulk density is a factor in determining crown fire type and crown fire rate of spread. Elevation influences fuel moisture content, mainly in regards to temperature. And aspect influences fuel moisture content and fire spread direction. And slope also influences fuel moisture content and the rate of spread. So, as you can see, each of these layers plays an important role in the overall prediction of fire behavior. And today, like I said, we're going to just focus on the fire behavior fuel model and demonstrate a few common modification tasks. So for those who may not be really familiar with what fire behavior fuel models are, a fuel model, or a fire behavior fuel model, is a set of fuel characteristics that would lead to a particular fire behavior, such as rate of spread or flame length under specific wind and fuel moisture conditions. So when I use the term model, or fire behavior fuel model here, I'm not referring to a computer simulation model, but I'm talking about a set of fuel characteristics. So these characteristics include things such as the amount or weight of the fuel, which we refer to as the fuel load, fuel loading, the fuel depth, and then also the composition of the fuel bed, or the proportion of the fine and moderately degree grass and shrubs. And fire behavior experts are familiar with these models. They use them in their work all the time, and they can identify them in the field. So, taking a look at the charts on the bottom of this slide, you can see that under a 5-mile-an-hour mid-flame wind speed and low fuel moisture conditions, and these are on flat ground, that we can see that fuel model TU5, which is considered a very high-load timber and shrub fuel model, would predict a rate of spread of 10 chains per hour and a flame length of around 7.5 feet. Also, looking at the map on the right, we can see that this TU5 fuel model, which is shown in the dark green, is fairly well distributed. So let's say, for our example, that the fire behavior experts had looked at both the map and the predicted fire behavior with this model and concluded that there's a possible accuracy issue in that this TU5 is overmapped and does not reflect what their expectations or observations in those areas. Earlier, we mentioned that LANDFIRE data is typically 3 years out of date the day it hits the shelves. So in areas that are heavily managed or receive a lot of natural disturbance, this can result in a data currency issue. So your critique becomes really important in catching these kinds of things. So in our example, let's assume that the local fire managers have identified that the effects from 2 adjacent prescribed burns are not reflected in the data. And I'm showing on the map where those prescribed burns would be with the red hashed polygons. So to recap so far, we're in step 3, we're reviewing our data, and now we want to reevaluate those data requirements because we've identified 2 issues. The first issue is an accuracy issue, and that is that local managers state that the fire behavior fuel model does not accurately reflect surface fire behavior in some areas. And this has driven us to meet some new requirements. So now we're looking at wanting to know something about the mapping rules so we can understand why fuel model TU5 is mapped where it is. We want information on predicted fire behavior, such as you saw in those charts. And we want local knowledge of observed fire behavior so we have something to compare it to. And some tools that we can use to help deal with this issue are GIS, the LANDFIRE Total Field Change tool, which I'll talk about more in the following slides, fire behavior calculators, local expertise, and published literature. Our second issue that we found was a currency issue, and we identified that there were recent prescribed fires and that they had invalidated the fuel and vegetation data in this area. So to alleviate that issue, we have a couple more new requirements, and that is that we now need geospatial data showing the location, extent, and severity of those prescribed burns, and information on the effects of what the prescribed burn has on fuel and vegetation. So again, we're going to use GIS, the Total Field Change tool, local expertise, We may include some fire effects models and published literature. So, fire behavior field models, as I mentioned earlier, are mapped using a rule-based approach. I can go into a little bit more detail here. Basically, each field model, each rule is identified as a specific combination of biophysical setting, existing vegetation type, and a range of existing vegetation cover and height that would lead to a particular fuel model. The LANDFIRE Total Fuel Change tool allows us to, so to speak, peek behind the curtain by linking LANDFIRE spatial data to the database of rules that were used to map fields across the U.S. So in this example, you can see on the second line, that the second rule, that in areas where the tree height is less than 5 meters, and this is within the Rocky Mountains of Alpine dry matrix spruce fir forest and woodland vegetation type. If the trees are less than 5 meters in height and at any canopy cover, we would assign a GS2 or grass shrub 2 fuel model. If the trees are over 5 meters and less than 40% cover, we would assign a timber understory 1 fuel model. And if the cover is greater than 40%, we would assign that timber understory 5 model that were questioned. Switching to the second issue that we identified about the prescribed burns, we know that the data is now out of date because of these burns. So burn severity is a measure of the fire's effect on vegetation and fuel. And as you can see in the lower right-hand portion of the slide, there are actually different rules to reflect where disturbances have happened. And those rules are going to vary by the disturbance type, the severity, and the time since disturbance. So if available, having geospatial burn severity data is really useful for updating our field and vegetation data. So originally, we reviewed our data, we set our objectives and reviewed our data, and we thought that we would just need the 8 standard layers that are used in fire behavior, geospatial fire behavior modeling. But then after our evaluation, we determined that in addition, we're going to need layers of biophysical setting, existing vegetation type, cover, and height, and recent disturbance severity. So moving into step 4 now, we're going to modify data. We now see that, now that we know that LANDFIRE maps fire behavior fuel model using a rule-based approach by UVT, one of our first steps in modifying data might be to go and see which UVTs the TU5 is being mapped to. So, just doing a quick visual analysis in GIS, as is shown in this slide, we can see that there's a significant amount of the TU5 associated with the alpine dry matrix spruce fir type. So on the left side, the dark green is TU5, and on the right side, the lighter green is the alpine dry matrix spruce fir. So the next thing we want to do then is to determine where the error is and decide whether you think the assignment is incorrect or if we're a different combination of variables that help improve the mapping. So the LANDFIRE Total Field Change tool helps us do both of those things. Assignments can be critiqued by comparing the modeled fire behavior to an observed or expected fire behavior based on expert knowledge. And the LANDFIRE Total Field Change tool has a built-in fire behavior calculator, as you see here, so that we can see how each of the fire behavior fuel models being assigned will predict flame length, the rate of spread over a range of different wind speeds, fuel moisture conditions, and so on. So let's assume, for our example, that the manager states that TU5 does exist in this vegetation type, but it's mainly in isolated pockets, and that there's just too much of it mapped in the area. So the LANDFIRE Total Field Change tool also allows us to easily modify rules and test our results. So as we see here, by changing the canopy cover threshold between TU1 and TU5, from 40 to 50%, we changed the proportion of how those fuel models are mapped on the landscape. So originally, we saw with the 40% threshold, the break point, we saw that 23% of our landscape was in 2U1, whereas 71% was in 2U5. By modifying that value from 40 to 50%, we now have sort of flipped the proportion, and we have more in 2U1, 56%, and about 38% in 2U5, and we can see how that plays out spatially on the landscape in the map. So I warned you that step 4 is the technical part, and here's where we get into the GIS and update our raster layers. So I'm not going to go into details about the different techniques, but I'm just going to state that there are multiple GIS techniques available for doing this. And basically what we're doing is we're just burning or stamping in the new disturbance into the old disturbance layer in this slide. Likewise, we would have to do the same thing to adjust our canopy cover based on burn severity. So again, there's multiple GIS techniques for accomplishing these tasks, but we would need to take our burn severity data, modify our existing canopy cover to reflect the effects of those burns, and then we would come up with our post prescribed burn canopy cover layer. So in reviewing our pre versus post fuel model data, we can see here that we've reduced the amount of GU5 and that it is mapped more accurately to those pockets of denser canopy cover that the managers had described. We can also see that in the area where the prescribed burn was, that we've captured the effect of the prescribed burns on fuel model. So that brings us then to step 5, where we are going to now conduct our analysis. So in this slide, I'm just depicting that I've used FlamMap 5, Fire Behavior Modeling System, to model fire behavior hazard, and I'm characterizing that hazard as things such as rate of spread, flame length, and as this map shows, ground fire activity or fire type. And then after we conduct our analysis, our final step would be to review the results and see if they pass the straight face test. And as I think I mentioned earlier, it's not uncommon for the results to highlight some hidden issues that you maybe don't see when you're just looking at the data. So all of a sudden you can see that you're either not getting enough ground fire behavior as you would expect, or you're getting too much ground fire behavior, or your rates of spread seem too high in certain particular areas. And you can dig into the data again and figure out what's causing those errors and hopefully remedy them. So to recap the process, our objective was to model fire hazard under a specific August weather condition, 95th percentile conditions in August. We initially identified that we needed the required fuel, vegetation, and topography data for spatial fire behavior modeling. And then upon our initial review, we identified 2 issues and reevaluated our data needs. So we found that there was TU5 seemed to be overmapped on the landscape, and that there had been 2 prescribed burns that had occurred after the currency date of the data. And we decided that we would now need additional information on land fire vegetation so we could assess those fuel model mapping rows and the monitoring trends and burn severity layer so that we could update for the prescribed fires. We then revised our data to account for the TU5 overmapping and the effect of the prescribed burns. And finally, we ran our analysis, our hazard analysis, in FlamMap 5. So as you've seen, the critique and modification of land fire data for local applications requires some expertise in working with geospatial data, as well as in the discipline for which you're applying the data. In this case, it was wildfire behavior modeling. Perhaps most importantly, though, is an understanding of the assumptions and limitations of the data you're working with. And the LANDFIRE website is actually a really great starting point to get this information. As far as time and expense goes, the time and expense is going to vary depending on the amount of review and revision you need to do. In general, I would say that finer scale assessments require more thorough review than broad scale assessments, and that for also I guess areas in the East Coast I've found and around the lake states where you have a lot of mechanical type fuel treatments going on, those typically take a little bit more time to deal with that data. And as an estimate for the fuel calibrations we typically do here at Teams, we usually like to spend a couple of days in the field and then hold a 1 or 2 day workshop with the local experts using the LANDFIRE Total Fuel Change tool. So if you choose to go through this process, some of the resources that are available are the Nature Conservancy Reviewing and Modifying LANDFIRE Spatial Data Products Guide, and that's available to you on the Conservation Gateway website. Also, Corey Blankenship and I, as I mentioned, are working on a more comprehensive guide that will hopefully be coming out late this summer or early fall. And this guide is going to give a more in-depth background as to how LANDFIRE spatial products are developed. And then it's going to have sections on common considerations for critiquing each of the different LANDFIRE data products, and then some examples using common tools and techniques for how to make updates based on some of the common issues that you may find. And then finally, for fire behavior modeling in general, there's a great guide available from the Wildland Fire Management Research, Development, and Application Group on the Frames website called Introduction to Fire Behavior Modeling. And lastly, there is support available. So the Nature Conservancy LANDFIRE team is always very helpful and willing to answer your questions or at least get you pointed in the right direction if they don't have the answers. And we at Teams have done a lot of this work around the country with various national forest partners. We've worked in the Lake States, the Southwest, and the Northwest. So just to throw my plug in for Enterprise, if you're unfamiliar with the Forest Service Enterprise program, we're basically a regular Forest Service employees that are Washington office detached that are available for national forests across the country to tap into if you need help to meet either short-term staffing needs or assistance